Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhamad Fauzi and my matric card number is DE190145. So we are from group A2.1 and group A2.1 consists of Aiman Fikrie bin Shafie and also Ahmad Mustaqim bin Rosli, and we are going to present for Power Engineering Lab 3 with the title of AC 3-phase to Synchronous motor. In this motor we present two connections, which is the star connection and delta connection. So I will present the star connection first. And so this is the system wiring assembly by using the star connection. I will explain in detail what is the equipment that we use and how to connect the from supply to the motor. So first of all, we have the variable DC power supply here, and then we also have the variable AC 3-phase supply, and we have two multimeter here, digital multimeter for the current and also the voltage, and then we have analog voltmeter and also analog ammeter, and then we have four power digital power meter for the voltage, which is voltmeter, current ammeter, power wattmeter, and also the power factor meter. These are all to measure the output for every line in the AC power supply, and for this analog and digital multimeter for the DC power supply. And then we also have the motor assembly panel, which consists of the stator, rotor, and coil, and we also have a motor drive to drive the rotor. Okay, next for the connection part, this motor need two power supply, which is the DC supply and also the AC supply. Then for the DC supply, it will connect it to the carbon brush here. So from the positive terminal, it will connect it to the ammeter here, analog ammeter, and then connected to the digital multimeter for ammeter, and then the output will go straight to the positive terminal of the carbon brush, and then the negative terminal of the carbon brush will go straight to the negative terminal of the DC power supply. For the digital voltmeter and analog voltmeter, it will connected in parallel because the voltmeter need to be connected in parallel to observe the output. And then for the stator, it will be connected with the AC 3-phase supply. So in the AC 3-phase supply, it consists of red, yellow, blue, and neutral line. So from the AC 3-phase supply, it will connect it in series with the 4 digital power meter here. From here, it will go to the voltmeter, ammeter, power meter, and also the power factor meter. Then the output of the power factor meter will be connected to the stator, which is the red phase will go to the red phase of the stator, yellow phase will go to the yellow phase of the stator, and same goes for the blue phase and neutral phase of the stator. And then from here, we will see that here is the star connection were made, which is the RYB will be connected to the stator, and then there will be a neutral line connected to the 3-phase here. So these are the star connection that we made at the stator, and we will see the output of the digital multimeter and also the digital power meter here. Okay, next the output of the motor will be tabled in the table 5.1, 5.2, and 5.3. So for table 5.1 is the data collection of the stator in the star connection. So it consists of the output from the digital power meter, which is the voltage, current, power, and also the power factor when we increase the braking load, which is from 0 to 0.8 Newton meter. So as you can see here that in terms of speed, the value of the RPM, which is around 3000 RPM. So when the braking load increase to 0.7, the speed will also remain the same to around 3000 RPM. But as we can see at the voltage here, the value of the red phase, yellow phase, and blue phase has a value around 145 and 144 and also 141 respectively. And then for the 3-phase, it was around 229 volt. But for the current here, we can see that the red, yellow, blue, and also the 3-phase, we can see that the value was increasing. For example, at the red phase, from 0.44 ampere, the value increased to 0.95 ampere. This is due to the braking load increase from 0 to 0.7, and the value also increased for every line, which is for yellow line, blue line, and also the 3-phase. And for the power, we can see that it also increased from red phase. We can see that 331.5 watt to 108 watt. This is all due to the load from 0 to 0.7. And also the power factor, we can see that at the red line, yellow line, blue line, and also the 3-phase line, we can see that the value also increased. For example, at red line from 0.47 to 0.77 as the load increased. Therefore, we can see that the current, power and also power factor were affected by the increases of the load, which is from 0 to 0.7. During the 0.8 Newton meter, we can see that there are no value of speed, voltage, current, power and also the power factor. This is because during the load were at 0.8 Newton meter, we can see that the motor started to stall and the value of this voltage, current, power and also the power factor were unstable. Therefore, we will need to stop the working operation of the motor because it cannot withstand the load of 0.8 Newton meter. Okay, next this is for table 5.2 data collection for armature in the star connection. As we can see, it consists of the DC voltage and DC current, and this is for the breaking load from 0 to 0.7. And as we can see here, this DC voltage here has a consistent value of around 13 volt. As the load increased from 0 to 0.7, the DC voltage remain the same at around 13 volt. And as we can see that DC current here, it has a fluctuating value because from at 0 Newton meter, the value is 2.4 amp, but the value increase until 0.3 Newton meter, which is at 2.6 amp, and then it goes down to 2.57, and then it increase to 2.6, and it decreased to 2.54 and 2.52. The value of current were not stable as the DC voltage. The last one, this is for table 5.3, which is for the calculated horsepower in the star connection. As we can see here, there is a load here from 0 to 0.7 Newton meter, and then this is the three-phase horsepower. We calculate the value of horsepower by using the power in the three-phase in table 5.1, and by using the formula of power divided by 746, and then we will get the value of this horsepower for every load. And as we can see here, as the load increase, we can see that the value of horsepower of the star connection motor was increased as 0.148 to 0.420 horsepower. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mustaqim dari Rosli. Okay, for system wire assembly using delta connection, for three-phase from three-phase supply, there are three line, which is red, yellow, blue. From three-phase supply, it will connect to 4 digital power meter, which has been set to voltage, current, power and power factor. Okay, from the digital power meter for power factor, it will connect to the stator, and from the stator we apply the delta connection here. Okay, from blue it will connect to the yellow, and red it will connect to the blue, and yellow it will connect to the red. Okay, then from rotor, it will connect only for the red line. It will connect to digital DC emitter, and it will connect to DC current, and from DC current it will connect to DC supply. From the DC supply, it will connect to the digital DC voltage and DC voltage. Okay, from DC supply, the neutral line, it will connect to DC voltage, and also will connect to digital DC voltage, and it will connect to the rotor. Okay, for table 5.4 data collection for delta, the speed that we get from the reading, we can say that the speed value is around 3000 for each value of the load. And for the voltage value, red, yellow, blue, it is decreasing when the load value is increased. For the current and power, the value of current and power is increasing when load value is increased. Okay, for the power factor is the power factor value is depend on the load value, so the value will not same and it will depend to the load. Next for table 5.5, data collection armature for delta, we can see for DC voltage reading, the value is almost same, which is around 13 volt, but there are a few value not same. For example, load 0.1 and 0.8, the value is 14.348 and 18.551. And for the value of the current, we can say that the value of the current is almost the same, which is around 2.4, 2.5, but not when the load value is 0.8. The value of DC current is 3.307. And next, for table 5.6, the calculated horsepower data for load value 0, the horsepower that we calculate and we get 0.134, 0.1 we get 0.158 from, and value load for 0.2 we get 0.21, the load value 0.3, 0.237, 0.4, 0.281. For value 0.5 we get 0.318, and value load for 0.6, 0.377 horsepower, and 0.7 load we get 0.414 horsepower, and lastly 0.8 value we get 0.2298. We can see here the value of horsepower is increasing when the load value is increased, but when the value load is 0.8, it will decrease to 0.298. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Fikrie Shafie. My message number is BE40301. Today I'm going to present for the two part, which is the stator layout of the delta wiring connection, and also for the graph for the star and delta connection. Then first I will present for the stator layout delta wiring connection. As we can see here, in the delta wiring connection, there will be no neutral involved. And for the coil, for the stator connection, inside the coil is the same with the star connection. Just the outer part of the stator coil is different. For the DC supply connection to the rotor, is also the same with the star connection. And then first, the red phase of the delta, red phase from the supply will connected to the input red phase here, and then it will connected to the two pole, which is from 6, and then from output of pole 7 it will connected to the output of pole 1, and then from the input pole 12 it will connected to the R phase, R prime output phase, and then from there it will connected to the input Y phase. And then for the yellow connection, yellow phase connection, it will connected to the input Y phase here, and then we will connected to the two pole here, which is pole 10 and 11, and from output of pole 11 it will connect it to the output of pole 5, and then from the input pole 4 it will connect it to the R prime output phase, and then from there it will connect it to the B phase, input B phase. And then for the blue phase, it will connect it in series with ammeter, and then from there you connect it to the input of B input phase here, and then from there you could connect it to the two pole, which is 2 and 3, and from output of pole 3 it will be connected to the pole 9 and 8, and then from the input of pole 8 you will connect it to the B prime of the B prime phase output, and then you connect it to the common, and after connected to the common it will connect it back to the R input phase. And then for the voltmeter, it will connect it in parallel with the R phase and Y phase. Next, for the calculated HP versus load torque graph. So for the blue color is the star connection 3-phase horsepower, and the brown color is for the delta connection 3-phase horsepower. And it can be observed for the star connection, it increased linearly, and then after it hit 0.7, when load torque equal to 0.7, the motor will start to experience stall condition, and then that's why there will be no value at 0.8. Likewise, the delta connection 3-phase horsepower, it also increased linearly, and then after that at 0.7 it will decrease to the certain value, which is 0.3 here. When load torque equal to 0.8, the calculated horsepower will be 0.3. And then for the DC current versus load torque graph, for the DC current load torque graph, there will be 6 graph, which is for the red phases between star and delta connection, yellow phases between star and delta connection, and blue phase between star and delta connection. So as you can see here, first for the red star delta, the blue color here, it's also increased, the graph also increased linearly, and then after 0.7 it will experience stall condition. And then for the brown color, for the delta connection, it also increased linearly, and then after 0.7 it goes up until 3.97 something at here. And then for the delta, for the yellow phase star, which is the gray one, is between in blue and red here. It's also increased linearly. After 0.7 it start to experience stall condition. And then for the yellow color here, the yellow graph color here for the delta, it also increased until 0.7, and after 0.7 it rose up until 2 ampere. 3 ampere. This is for the stator current. And then last, for the blue phase star, which is the red one, also increased linearly. After it reaches 0.7, it will start to experience stall condition. And then last, for the blue phase delta connection, it will increase linearly, and after 0.7 it goes up until 1.68 ampere. Last but not least, for the graph, which is the DC current versus load torque graph. So as we know, the DC current is for the rotor part. So there will be two connections, which is star and delta connection. The blue color of graph shows the star connection, and the red color here shows the delta connection. So from the star connection, it can be observed that the graph also like a constant graph, and after it hit 0.7, when load torque equal to 0.7, it will start experiencing breakdown or stall condition, and that's why there is no value at 0.8. Last, for the delta connection, which is the red color, it's also like a constant graph, and after 0.7 it will goes up until 3.6 something, 3.307 here, which is the DC current of the rotor. I think that's all for my part. Thank you.